Hello and welcome to HaptiVerse, a system for haptic communication and haptic pattern design. Developed within the EU-funded project Muse IT, HaptiVerse explores how tactile signals can enrich communication, accessibility, and user experience. HaptiVerse is a multi-component haptic communication system that enables communication one-to-one or one-to-many in close proximity or across distance. Its aim is to support meaningful, expressive communication through touch. Individuals living with deafblindness use various modes of tactile communication, such as tactile sign language, protactile language, social haptic communication, print on palm, Tadoma, Braille, and finger Braille. HaptiVerse draws on these and translates some of the tactile touch messages into digital haptic expressions. The goal of HaptiVerse is to offer a complementary communication mode for, by, and with people with deafblindness. It draws on signs already familiar to the community to support intuitive recognition. The system further facilitates learning by enabling users to practice and internalize haptic patterns at their own pace. HaptiVerse enhances independence by enabling users to receive information without close physical contact with another person. It supports communication to multiple people at the same time and works even when sender and receiver are at a distance. In upcoming versions, communication can be initiated by voice or text commands, which are translated into haptic patterns, or what we call haptograms. Furthermore, as language is a dynamic, living system that evolves organically based on the culture and active social participation of its speakers, HaptiVerse aims to enable the community to expand the shared vocabulary by co-designing new meaningful haptic expressions. HaptiVerse comprises multiple components. HaptiBoards are modular haptic control boards. They use a bus architecture to support multi-channel design that works with many types of actuators. A special version of control board can support multiple buses to scale the number of haptic outputs, offering flexible customization. HaptiNet is the web-based application for building templates, creating haptograms and sentences, organizing vocabularies, and managing users and administrative settings. HaptioTech is the shared database of haptic patterns from both professionals and end users. It is managed through Haptimux and allows the vocabulary of haptic signals to grow as the community contributes new patterns. Haptimux is the haptic signal routing system. It distributes haptic patterns efficiently to different actuators or to multiple users. This makes one-to-one, one-to-many, and multi-user haptic interactions possible. HaptiBridge is a communication link built on a Raspberry Pi. It communicates with Haptimux over a WebSocket connection using a lightweight Python script. The protocol is simple, making it possible to integrate into future solutions, including mobile apps. HaptiMesh and HaptiWare are physical interfaces designed to deliver haptic feedback through arrays of actuators. Different versions are shaped for placement on clothing, surfaces, or seating. They deliver detailed haptic patterns directly to the body. The HaptiBoard modules include multiple ports for actuators, USB-C connectivity, and optional power inputs. Their compact design allows flexible combinations depending on the application. The haptic wearables use multi-layered membranes made from heat-bonded technical textiles. Each module includes pockets for actuators, channels for cable routing, and materials chosen for stability on curved body surfaces. The modular design allows rerouting, reconnecting, and customizing arrays based on body proportions or specific applications. Additional outer layers can shape how sensations are diffused or textured across the skin. Haptic modules can be positioned along the shoulders, upper arms, lower arms, sides, back, or waist. This ensures that signals are delivered to consistent, meaningful areas of the body for clear interpretation. Last but not least, HaptiDesigner allows users to create, edit, and refine haptic patterns. It offers real-time testing with haptic devices, making it possible to adjust patterns immediately and deploy them in different applications. In this slide, the image shows an example of a haptic pattern emulating the social haptic communication sign for room. HaptiDesigner supports creating such patterns visually and testing them on connected devices. HaptiDesigner includes real-time remote access and supports multiple interface options that allow designers and end users to work together from local or remote locations. To see how exactly this proof of concept haptic communication system works, please see our related demos. For more information, please feel free to contact us or visit our website.